In this question, A, B, C are the three sets. The function f is defined for A to B and G function is defined for B to C. Which is that one, in the function f, A is the domain, B is the codomain. In the function G, B is the domain, C is the codomain. Then we have to answer the questions. Okay, before that, we have to, from the given two functions, we can say that G circle is a well-defined function. Why? Because the f codomain value is B and the G domain value is B. Those are the subset of the domain value. That's why this G circle f is the defined function. So we can write that domain of G circle f, which is domain and codomain, we can write it, the f domain is the A and G codomain is the C. We can write like this. First we write the composite function by the definition. By using the definition, this is defined function. We can how to write the domain and codomain. We know that one, any composite function, second function domain is the domain of the composite function. Then first function codomain is the domain of the composite function. Codomain of the composite function. Okay, that's why in that way I can write the A to C. Now, first question. In the first question, what we have to do? If f and g are one-to-one functions, then prove that G circle f, the composite function G circle f is one-to-one. We have to prove it. So, how can we prove it? So, we can prove like this. If G circle f is one-to-one function, you have to, if you take the images with respect to x and y, okay, na? For these two inputs, image of these composite functions are equal, we are going to prove x is equals to y, we are going to prove. Okay, but we given according to f is one-to-one function, g is one-to-one function. How can you define that one? F is one-to-one function is given, na? One-to-one function we can write f of x is equals to f of y. If the images are equal, so input should also be equal. Similarly, g function also. G is also one-to-one function is given, na? So we can say g of x is equals to g of y. G of y, we can say x is equals to y. What is nothing but here f of whatever the inputs are inside bracket inside values, those are equal. You can do that. Here also inside input values are equal. In that way, we can say f1 1-to-1, g also 1-to-1. So these 2 points keep in mind. Now I am going to take the image of the x input. I am applying to x image of the composite function, y image of the composite functions are equal. I am taking first taking this one. Now I am applying the both sides, removing the circles and putting the brackets for the f function. Here f of x, f of y. We know that g is the one-to-one function. Then how to write it? Whatever the bracket values on both sides, those also equal. That's why in the g of inside, whatever it may be x, it may be f of x, those functions, those here functions are there. So these inside values are equal according to the one-to-one function. These inside bracket inside input values are equal. But these are functions now. Okay, f of x is equal to f of y because of g one-to-one function. I can equate f of x is equals to f of y. We know that f is also a one-to-one function. Na? Again, the f inside, these are the inputs for the function f. Now these are also equal according to this function. According to the f is one-to-one function, I can equate f y x is equals to y is equals to, both are the x is equals to y is that. Okay, both are the equal. Then we can say, firstly we can taken for x image, y images I have taken equally. Finally, these inputs also, these input domain values also equal. That we have proven. That's why G circle f is one-to-one function.